In January 2005, NASA sent a special probe into space. Its purpose was to uncover the mystery of where Earth's water originally came from. This spacecraft, named Deep Impact, traveled 270 million kilometers before arriving near a comet. Inside that comet lay secrets scientists had been chasing for centuries. Welcome back, dear viewers, to Amir TV videos. Across the entire universe, there's only one place we know of where human beings can survive: our planet Earth. It almost seems as though Earth was designed especially for humans. It contains everything life needs: water, food, and oxygen. Somewhere in this vast universe there may be other such worlds, but at least for now, Earth is the only one where humans can live unaided. But 5 billion years ago, Earth wasn't even there. The very spot where Earth and the solar system are found today, on the edge of the Milky Way galaxy, was once nothing but a massive cloud of dust and gases. So, what happened inside this cloud that transformed it into the planet we live on now? That cloud of dust and gases is known as a molecular cloud. Within it were particles of dust, sand, silicon, and traces of metals. These clouds were born from the remains of stars that had died. In the early universe, stars that burned through their fuel exploded, scattering their material into space. Unlike the clouds in our sky, these looked completely different, later captured with the Hubble Space Telescope. Amazingly, some molecular clouds stretched 100 light-years across. Put simply, they were about 6 million times larger than the distance between Earth and the Sun. It is within these giant clouds that stars and planets take shape, and the force that makes this possible is gravity. The very same gravity that arises because objects with mass attract one another. The bigger the object, the stronger its gravitational pull. In the molecular cloud, particles began clumping together due to gravity. Large particles pulled in smaller ones, and as they collided, they released energy, heating up the core. For millions of years this continued, until the core grew larger, spun faster, and became hotter, finally igniting into a giant fireball: our Sun. The leftover material from the molecular cloud started orbiting this newborn sun. From this dust and gas, the planets of our solar system and their moons gradually formed. But how exactly did this process unfold? The idea that stars form within molecular clouds was first proposed back in the 1700s by German philosopher Immanuel Kant and French thinker Pierre-Simon Laplace. At that time, it was only speculation. By the 1920s and 1950s, telescopes had improved, yet peering inside these clouds was still impossible. In the 1970s and 1980s, however, radio and infrared telescopes gave scientists a way to see within, and they actually witnessed stars being born inside. This confirmed the old hypothesis. But the question remained: how does the process even begin? In March 2003, a breakthrough experiment on the International Space Station offered the answer. Astronaut Don Pettit tested how objects behave in microgravity. He made water bubbles, dissolved powders, and spun a bag filled with salt. Unexpectedly, this experiment solved an ancient puzzle. In space, the salt grains stuck together. That's because particles in microgravity naturally attract each other. Scientists believe the same thing happened inside the molecular cloud. Dust particles, all orbiting in the same direction around the sun, gradually clumped together like the salt grains. Around 4.5 billion years ago, these clumps grew until one became as big as a mountain, about 1 kilometer wide. Its gravity then pulled in even more matter, working like a vacuum cleaner in space. Over the next 30 million years, this process continued. Roughly 20 planets formed, all orbiting the sun. But as they grew, their gravity pulled them into collisions. Each crash merged 2 planets into one larger world. Eventually, only a few were left: Mercury, Venus, Mars, and of course, Earth. Yet Earth back then was not the calm blue planet we know. It was molten and fiery, so hot that any water would have instantly evaporated. Earth needed to cool before it could support life. But before that, it faced another huge danger: solar storms. These violent blasts of radiation from the sun strip away planetary atmospheres, and that's why Mars couldn't hold on to life. So why did Earth survive? The answer lies deep in Earth's core. When Earth formed, heavy metals like iron and nickel sank to the center. Rotating molten iron generates a magnetic field, and Earth's iron core created a powerful magnetosphere. This invisible shield stretched about 370,000 kilometers toward the sun, nearly as far as the moon, and millions of kilometers away on the far side. It blocked deadly solar radiation. At the poles, where the shield was weaker, the radiation slipped in, lighting up the sky as the northern and southern auroras. Earth had survived the storms, but it was still not yet ready for life. Then came a dramatic planetary collision. During the 1960s Apollo missions, astronauts brought back moon rocks. They weren't identical to Earth's rocks, but their oxygen isotopes matched, showing the moon was once part of Earth. The cause? A Mars-sized planet named Theia. When Theia smashed into Earth, it unleashed colossal energy, blasting molten rock into orbit. Over thousands of years, those fragments clumped together and became the moon. In the beginning, the moon was about 15 times closer than today, appearing enormous in the sky. Slowly, it drifted away at a rate of about 1.5 inches per year. This collision also tilted Earth's axis to 23.5 degrees, giving us seasons. Without that tilt, Earth would have been stuck with the same climate year-round. Thanks to it, we enjoy different seasons, monsoons, harvest cycles, and rainfall that provides us with fresh water. The moon also stirred up the oceans, creating tides. These tides spread nutrients vital for sea life. Without them, nutrients would stay stuck in small areas, leaving most of the oceans barren. Even so, one essential ingredient was still missing: water. So where did it come from? That's why, in January 2005, NASA launched the Deep Impact mission to Comet Tempel 1, 270 million kilometers away. On July 4, 2005, its 350 kg copper impactor slammed into the comet at 38,000 kilometers per hour, carving out a crater. Spectroscopic analysis revealed ice, frozen water, inside the comet. This confirmed that comets carry water. But then, how did comets actually reach Earth? The answer lies with Jupiter. Being the largest planet with immense gravity, Jupiter disturbed the orbits of countless asteroids and comets, pulling them away from circular paths into elliptical orbits. Many were then drawn toward Earth. Geologists discovered that water didn't arrive at Earth's birth, but about 500 million years later. The proof is in a mineral called zircon, which only forms in the presence of water. Containing uranium, these crystals can be precisely dated. The oldest zircons, about 4 billion years old, show that water arrived long after Earth was born. To recap, Earth formed out of a molecular cloud. A Mars-sized Theia collided with Earth, creating the moon and tilting its axis. Jupiter's gravity redirected comets, delivering water. Earth cooled, gained seasons and tides, and slowly developed the right conditions for life. By this time, Earth's temperature had dropped to around 100 degrees Celsius, but one last key ingredient was still missing: oxygen. And so, I leave you with this question. How did oxygen first appear in Earth's atmosphere? We hope you liked this video from Amir TV. Please don't forget to like and share. Thank you for your kind comments, and see you in the next amazing video.